Not every problem is a neat rows and columns problem. Sometimes you need a database that's lightning fast, endlessly flexible, and can handle millions of requests a second without breaking a sweat, whether you have 10 users or 10 million. That's DynamoDB. It's a different kind of database from the traditional sort, and once you understand how it thinks, you'll know exactly when to reach for it. Let's break it down. To get DynamoDB, you need one quick comparison. The traditional database, the kind most people picture, is relational. Data lives in tables of rows and columns, with a strict structure defined up front, and tables can be linked together. Powerful and precise, but that rigid structure can get in the way when you need to move fast or scale massively. DynamoDB is a NoSQL database. NoSQL just means not the traditional relational model. Two things make it different. First, it's schemaless. You don't have to define every column in advance. Different records can have different fields. Second, it's built from the ground up to scale horizontally, to spread across many machines and handle enormous traffic smoothly. So, relational is the structured, rule-following option. DynamoDB is the flexible, built for massive scale option. Neither is better, they're for different jobs. DynamoDB has its own vocabulary, but it maps neatly onto ideas you already know. You still store your data in a table. Inside that table, each record is called an item. That's DynamoDB's word for a row. And each piece of data inside an item is an attribute. DynamoDB's word for a column value. The big difference from a relational table, items in the same table don't all have to look the same. One item describing a customer might have an email and a phone number. The next might have an email and a mailing address. There's no rigid template forcing every item into the same shape. That flexibility is a core part of the appeal. Table, item, attribute. Hold on to those three. Here's the most important concept in all of DynamoDB. The primary key. Every item in a table is uniquely identified by its primary key. It's how DynamoDB finds your data. And there are two styles. The simplest is just a partition key, a single value, like a user ID, that uniquely identifies each item. Hand DynamoDB that key, and it returns your item almost instantly. The richer style adds a sort key alongside the partition key. Now the partition key groups related items together, and the sort key orders them within that group. Picture a messaging app. The partition key could be a chat's ID, grouping all its messages, and the sort key could be the timestamp, keeping them in order. Together they pinpoint any single message. Get the key right, and DynamoDB is blisteringly fast. Get it wrong, and you'll fight the database. Which is why keys deserve real thought up front. Let's go one level deeper on that partition key, because it's the secret behind DynamoDB's famous scalability. Behind the scenes, DynamoDB spreads your data across many servers, called partitions. When you save an item, DynamoDB runs its partition key through a function that decides which partition it lands on. That means your data is automatically distributed. No single machine has to hold everything. This is why DynamoDB scales so smoothly. As your data and traffic grow, it just spreads across more partitions in the background. You never rack a bigger server. The database quietly grows sideways. The practical lesson: choose a partition key with lots of variety, like a user ID, so your data spreads evenly. A key with only a few possible values would jam everything onto a few partitions, and you'd lose the magic. One more practical choice: how you pay for and handle traffic. DynamoDB gives you two modes. On demand. DynamoDB automatically handles whatever traffic you throw at it, and you pay per request. It's perfect when your traffic is unpredictable or spiky, or when you just don't want to think about it. Provisioned, you tell DynamoDB upfront roughly how much traffic to expect, and you pay for that reserve capacity. It can be cheaper for steady, predictable workloads where you know what's coming. The simple rule: unpredictable or just starting out, on demand. Steady and predictable and watching costs, provisioned. So when should you actually pick DynamoDB over a traditional database? Here's the honest version. Reach for DynamoDB when you need massive scale, very fast and predictable performance, and your access patterns are simple and known. Look this up by its key. It shines for things like user profiles, shopping carts, session data, and gaming leaderboards. Lean toward a relational database when your data is highly interconnected and you need to ask flexible, complex questions across it that you can't predict in advance. It's not about which is newer or cooler. It's about the shape of your problem. Let's stack it up. DynamoDB is a NoSQL database, schemaless and built for huge scale. You store items made of attributes in a table and find them by their primary key, a partition key, optionally, with a sort key. That partition key spreads your data across many servers, which is how it scales so effortlessly. You pick on-demand or provisioned capacity, and you reach for it when you need speed and scale over complex flexibility. That's DynamoDB, flexible, fully managed, and built to scale to almost anything. If this made NoSQL click, hit subscribe. We're explaining AWS one service at a time. And let me know in the comments what to break down next. See you in the next one.